Hi, everyone. So I'm going to talk to you today. I'm going to allow you to keep all your money, and I'm going to show you how to use OpenStack, either whatever your use case is. You're an application developer, you're just consuming an OpenStack cloud, you want to deploy an OpenStack cloud. I'm going to show you how to do it with open source software. And we're also going to learn how to do it consistently, because I'm also going to tell you the truth about OpenStack clouds. So I'm Mike Perez. I've been a contributor for OpenStack for a bit. I'm a developer coordinator at the OpenStack Foundation, helping with cross-project issues. Along with that, I serve as a member of the technical committee, following the OpenStack governance and monitoring that, as well as a core developer for the OpenStack project Cinder. It's a block storage project. I've also served as the project technical lead for the Cinder project as well for a couple of releases. So, in the OpenStack mission statement, I like to refer back to this in this presentation, specifically for highlighting several things in there about being interoperable between deployments, as well as to make it easy for our users and operators to actually be able to deploy public and private clouds. So initially, just as Monty liked to do for his keynote, he likes to refer to this image. I also like to refer to this image for all my presentations as well, because this is exactly what I think OpenStack should look like for you as the person that is consuming an OpenStack cloud. You know that there are these services that you want to consume. You don't necessarily know about the complexity that exists inside of OpenStack, and nor should you. If you are an end user, you are somebody that wants to consume resources that are readily available. You might have requirements on those resources, but otherwise you don't really care if the cloud deployer is using some hot storage that is popular today. All you care about is that you get a volume and you can attach it to a VM maybe and consume it. So, as I was saying, sometimes things get a little bit more complicated than just this. And a variety of people have ideas of what they think of OpenStack Cloud. They might have something beyond those core services of just having storage and networking and compute. So we want to be a little bit more inclusive. Okay, so we have this idea called the Big Tent. It was also spoke about in Terry's talk, and specifically from a governance standpoint, we wanted to be more inclusive. We wanted to allow, without having to spend a whole time evaluating projects and just wasting people's time and what is a good idea, what's not a good idea. Instead, having a way to accept these programs or these projects so that they could be part of the OpenStack initiative as long as they're following our principles. And then so this created some confusion of what people thought of OpenStack, mainly in the public, headlines and whatnot, of thinking that I have to basically deploy all these services as well as core services. And as you can see here, there are a variety of services like DNS as a service that you may have not known about. There's Sahara for data processing, but along with that as well, there are these core services that we have been, for quite some time. But I'm here to tell you today that you don't have to deploy the world in order to run an OpenStack cloud. You don't have to deploy all 50 plus projects to be powered by it. And the way that I like to show people of how you do this is specifically you could go, Jonathan spoke about this earlier with the OpenStack Marketplace. And well, not in the OpenStack Marketplace itself, but inside of what we have on the OpenStack org site, the Project Navigator. And so if you go to navigate to the site, you could see a variety of the core services, and you can see optional services as well. And what's great about with all these services listed out is you could see metrics information based off of how mature the project is. And this is evaluated by a variety of different things, such as does the project, is it supported by a variety of application or software development kits? Is it, do they have installation docs so you even know how to use the thing? Do they follow certain stable procedures that we have defined inside of OpenStack? All of these are things that set whether or not, how comfortable we feel with the project. Along with that, though, there are sample configurations. So I mentioned before that with your OpenStack cloud that you're deploying, you don't have to deploy the world, right? You have a particular use case that you're trying to solve, a problem that you are coming to a cloud a reason why you want to deploy a cloud. And so these sample configurations, once again, you could go to the OpenStack org site and you can see a listing of a variety of sample configurations. So for example, here's for the use case for high performance computing. And here you can see that there's the core services, some of them are marked out, and then there's some additional optional services. There's cases for big data, as well as database as a service, and here's another one for video processing. And you can see, again, some core services that are highlighted that you would deploy for this case. And what's great about this is there's also real case examples that are linked in, and you can actually see how some of these people who are deploying OpenStack today are using these services and how they're successful with it. So, a checkpoint here that I've already explained to you is a big tent generally for you as the public and somebody that wants to deploy an OpenStack cloud. It's not that big of a deal. You should only care about the minimum of what you need for your use case in deploying an OpenStack cloud. And we provide a variety of different ways for you through the project navigator to navigate through these projects, to get to know these projects, where are they at, who's developing them, and then also to know which projects exactly do you need to deploy for your use case. So taking back from the Vancouver summit, and one of the keynotes, there was for the idea for having federated clouds. And with the federated clouds, we wanted to have an idea where from public clouds, you can have a way so that you can basically go across from each public cloud to using the resources, right? You want to consume compute resources from one cloud to another public cloud. And maybe you want to use storage from another public cloud. But the point is, though, is that you want to be able to identify yourself, authenticate through those different public clouds, and you want to have that identity shared across. But unfortunately, with the state of consistency, this is not totally a thing today. And in fact, it hasn't been really like a requirement at all in the public for deploying this thing. There are also programs that are working on things like this to improve this, but they weren't exactly defined then yet. But we as a community are working on this problem, and there are ways around this. So I'll talk about those later, though. But to go along with more with inconsistency issues, here's a list of inconsistencies that exist for a variety of public clouds for just getting a public IP. This is actually taken from a library that deals with inconsistencies called Shade, which I will talk about later. But these are just what it takes to get a public IP from a variety of public cloud providers that are deploying OpenStack. And Shade is an example of something that has to work through these inconsistencies. So how are we as a community trying to fix these problems? So incoming with DevCore. DevCore sets requirements. They define them by capabilities in code. They will take in OpenStack projects that are deemed mature, and they will actually have a lot, based off of the tests, they will set tests to run across for these different public clouds. And this right here is setting the minimum standards for products that are going to label themselves OpenStack. So once again, going from the OpenStack org site, Jonathan was talking about earlier with the marketplace, you could see basically at the very beginning, like we could take a look at some public clouds that meet some of our requirements. So for example, I could take a look and I could zoom in on this map and I can see a variety of public clouds in Czech Republic. So for Czech Republic, there will be Ultimum. And then I could see based on, which test and which version of OpenStack that these public clouds are supporting. So I could go into detail for one of them. So for VexHost, for example, and I could see the API versions that they support. And then along with that, I could get more details and sign up with that public cloud if I want to. So going back to my original statement with users that just want to consume OpenStack clouds, you want resources readily available. You have requirements with those. And all without having stability or performance holding you back. So, and along with that though, it kind of struck a note with me with my friend Flanders. He works at the OpenStack Foundation as well. And he told me that while it's great that this is all open source, don't expect users and operators to roll up their sleeves. He either really said this or I'm just paraphrasing and making it up, but basically it struck a note with me because me, for myself, I have been part of open source, since I was 11 years old. And it's always been natural to me that this is a wonderful thing to be able to fix the problems myself. But I can't expect you as the audience that maybe just wants to use OpenStack and not fix my problems. So again, let's talk about how we as a community are trying to deal with these inconsistencies and make things better. So the first thing I'd like to talk about is with the OpenStack client. Right now today, there are a variety of clients that exist for individual services. And initially, first of all, when you want to authenticate with any of those services, you have to typically have environment variables that will set how you log into that. It might be username and password as well as like a project that you're part of. But let's just say that you source environment variables to authenticate yourself. And then you use these Python, command line interfaces, or just command line interfaces that read these environment variables to authenticate you. Switching between different clouds makes it kind of difficult. Also, not having that idea with federated clouds kind of like makes this a little bit harder. Also, using these clients require you to know what the heck a Nova is and what the heck a Cinder is. I mean, how many code names have you heard today? And you have to keep looking up what each one of these are. Wouldn't it just be great to just say, I want to create this resource, or I just want to delete this resource or whatever. But along with that though, these clients have inconsistencies in themselves. So for example, if you wanted to set a quota, if you're an operator of a cloud and you wanted to set quota for Nova and set quota for Cinder, I will tell you today that they are completely different interfaces. They're not consistent. You would think I just want to set quota for vCPU and memory for a particular user or project, or maybe I want to set gigabytes and number of volumes that a project or tenant or project and user could create. Those APIs, those command line interfaces, completely different. This is what the OpenStack client seeks to fix. Along with doing that though, using a consistent set of verbs. So I would like you to think, instead of saying boot servers, say create servers. Here's an example of OpenStack client usage today. So this has OpenStack server create. You could see that you specify a flavor. The flavor is basically just what are the specs to that particular VM that you want to create. What's the size of it? What image do you want based off of it? And also, what do you want to name it? Instead of saying that for create volume, you would say exactly the same as saying OpenStack volume create. Size, you specify the size and you give it a name. Instead of saying attach a volume, say add a volume to a server. So again, with consistent verbs saying OpenStack server add volume, a name for the server that you want to attach the volume to, and then the name of the volume that you want to attach. Along with that, create volumes with images. So again, OpenStack volume create, you're specifying a size, you're specifying an image, and then you give it a name. These are like a little bit more predictable things. And don't set quotas like this. This is exactly what I was saying earlier. You have to actually know the difference, that you have to know that Nova has instances and RAM and volumes and snapshots in this form, and you have to set them in separate commands like this, but instead, do it all in one. It'll do multiple API hits, but it's all in one command. You can also do this for additional services as well that have quotas. So as an example though, we'll go ahead and we'll initiate with the OpenStack client. We're going to go into this really neat mode that it has called interactive mode. And so we're basically using this option called OS Cloud that allows us to specify which cloud we want to use. And I'll talk about that more later, but right now assume I'm using the Stream Compute cloud, and I'm already authenticated. And I just did an image list, and I got a list of images from Stream Compute. Now I could go ahead and I could specify that I want to create a volume based off of one of those images that it listed off. So a volume create image, specify the image that it gave me in the listing, specify a size and a name. And then I have a volume created, or a volume that is going to be created, rather. And that's it. So that's pretty predictable right there. From there, I'm going to go ahead and I'm going to create, first I want to create a server, but in order to do that, I need to get the flavor listing. So I could just say flavor list. These are the flavor listings for that Dream Compute cloud. So now I could go ahead and I could do a server create with that flavor, and I can attach that volume to it. So all I'm going to say though is server create. I do a -- volume option with that volume that I created initially off of a Ubuntu image with one of those flavors that it's listing to me. And I happen to know my SSH key is called launcher, and I'm going to name this VM test. And so along with that, it'll go ahead and it'll create the server. And then I can see from the Dream Compute dashboard, after refreshing it, that it'll have that VM listed. How many people just learned about OpenStack client today? And how many people have been using just the regular clients alone? Nobody? Okay. Well, start with OpenStack client and let us know what you think. Cool. So we can see that the VM is being created and everything. And so VM is being spawning up. It is launched. It's active. We're excited, and let's see. Okay, so now we're going to do the unthinkable, and we're going to assign a public IP to this. So typically, you would have to jump a little bit of hoops to actually make this happen. It just so happens, though, that we could just get a listing of the floating IPs. We have some magic that's happening with OpenStack client letting us do this, but we get a listing of the IPs, and now we can add that IP to that VM, so now it has a public IP. And then we can also do a listing to make sure that that floating IP got actually assigned to that VM. And then we should be able to simply be able to SSH into that VM with that public IP. So now you have seen an actual volume be created off of an image, booting that to a server, and then assigning a public IP and accessing the VM. So you have just experienced a working flow of OpenStack. And everything seems to be fine. We SSH in. And I did that on the flight over here while holding a glass of wine. So it was an easy demo to do. Also using the Wi-Fi on the plane as well. So, in review, take a picture of this if you want to remember everything. But basically, we instantiated an interactive mode of the OpenStack client so that we could be in interactive mode. And we got an image listing. And then we took one of those images listed and we created a volume off of that, given a size of it as well. Along with that, we got a listing of the flavors available from the cloud that we could specify for a size for the VM that we want to create. And then we got a listing of the floating IPs and we assigned it to that VM, to which then we were able to SSH using that public IP. So let's talk about authenticating. So with federation being not a so common thing yet inside with public clouds, and also a variety, this is not so much of an issue anymore. It's very well improved, I could say, with a variety of deployments not having differences and using different APIs for Keystone. As well as some deployers at one point not using Keystone. I don't even know how that's even possible. But how do we get around that? So initially, right, I was talking about earlier with typical OpenStack clients, you would normally use environment variables. Typically, it's stored in, and you source that file that you have all your environment variables in, and you have to enter a password, and then you can start running commands with OpenStack clients. And so you can see I'm like sourcing from one file to another to switch from different clouds. First I was doing Dream Compute, now I'm doing Ultimum, and I'm getting different flavor listings from each one of them. Now, this is kind of annoying that I have to keep injecting environment variables just to be able to log in from cloud to cloud. I'm also a believer that authenticating in sourcing any sort of files to inject environment variables was so 6 years ago. Instead, I would tell you that there's this magical configuration thing that Monty was talking about that hopefully you maybe never really see, but you can specify a config file, and it's called Clouds YAML. The project is called OS Client Config, but it's a Clouds YAML file, and it's basically just a listing of all the profiles of clouds that you have. So here's an example. Monty gave an example earlier, but these are my clouds that I have. I have a Dream Compute cloud, I have a Rackspace cloud, InterNAP, and Ultimum, and I also have Nectar. I also hid all of my authentication information in there, but like you could see that I have these profiles. So with that in mind, an example of being able to switch from one cloud to another without having to enter a password and sourcing files to inject environment variables, simply it would be easy to just say to switch from one cloud to the other, the name of that profile that I have identified with that authentication information. So if I want to get a flavor listing from all these different clouds, I just have to specify the option in OS Cloud of that profile name that I have specified along with its authentication information. So again, an example with that is I could go ahead and I could do, starting with Dream Compute, a flavor listing, and there's this list of flavors, and then I could go ahead and I could switch over to Ultimum and get a flavor listing of that. And then there you go. So switching between clouds, authenticating just easily like that. So this is all using still OpenStack client, but specifying that Clouds YAML file in my home directory. Okay, so let's talk about Shade. There's a lot of magic stuff happening here and dealing with some of the inconsistencies I was talking about earlier. And this is where this Shade SDK comes in. And you can pip install it today and play around with it. You can also read documentation on using it right there. So Shade is a Python software development kit. Allows you to go ahead and interact with OpenStack clouds using Python code. But what I really like about Shade a lot is that it has that same mentality that the OpenStack client has in just dealing with resources and interacting with those resources. But instead I'm interacting with them as if they were Python objects. So at the very beginning of this code, I'll kind of just go real quickly line by line, but at the beginning I want to instantiate a cloud. So I have Shade OpenStack cloud and I instantiate with Dream Compute. Dream Compute, again, is coming from what we were building off earlier with the Clouds YAML file, right? This is my profile name, and I have a way of how you authenticate to Dream Compute. Along with that, now that I have the Dream Cloud that is using my Dream Compute authentication information, I can get an image from that cloud. And this is great because I'm saying Dream Cloud, get image, and this particular image that I know that is listed off of Dream Compute. And along with that, I could get a flavor, and then I can do an action of create a server, and I could specify a name for it, an image, a flavor, and here's a really neat feature right here. I can say auto IP true. Those 5 bulleted lists of inconsistencies in dealing with getting a public IP in the variety of public clouds, this right here, this option just takes care of all of those problems. So I will always have an auto IP will always get me a public IP to my VM. And then I can specify to wait, so it's synchronous, and then I can get the server, and then I can list out the public IP. So we will do a demo of doing that. So again, it's the same exact code. We're going to go across the world, and we're going to start with Dream Compute, and we're going to go to Rackspace, to InterNAP, and to Ultimum. I know there's a variety of other clouds that I could be going to as well. But this is pretty much that same code I was showing you, but it's special for each cloud and their flavors and their images that they have specified. And then at the very end, I'm going to print all of their public IP addresses. These may or may not have inconsistencies in them, but it's mainly to demonstrate of just simply working across public clouds. So, along with it, we're going to start with Dream Compute, make it so. So there we go. We have the Dream Compute. In Dream Compute, we have a VM spawning, and we're supposed to get a public IP from it. And then so there we go. It loaded, and we have a public IP. It's active. There's a public IP. Excellent. So now Rackspace is going to launch. So here we go. We'll switch over to the dashboard. And so I'm just doing this all from the Python SDK. And you could do this with a variety of resources, not just VMs, of course, inside of OpenStack. So there we go. We have a VM inside of Rackspace now with a public IP. Internap was pretty quick. It's already done. And Ultimum is being launched now. So we'll refresh the Internap dashboard. And so there we go. It's active. It has a public IP as well. And Ultimum should be done shortly as well. Building, spawning. Okay, there we go. So it's active and it has a public IP. And there's all the listings of all the public IPs. So we just went across the world, OpenStack clouds, launching public IPs. Thank you, Monty, for your generous contribution. Yeah. Feed his narcissism. Okay, the last piece that I would like to talk about Monty's work, now that I know he's here, is Ansible and OpenStack. I'm not just favoring Ansible here, but I like to talk about this case because it builds off of everything that I've been talking about here. It's using Shade, that SDK that I was just talking about. It's also using Clouds YAML as well. And it's allowing us to do all this with some awesome orchestration goodness. And yeah. So we're going to do a little last demo. This is my last thing, promise. So we are going to go ahead and we're going to launch a VM in Dream Compute. Basically specifying flavor, auto IP. Also has that cool auto IP feature. Specify key, wait for SSH port 22 to be available. We're going to add Dream Compute to an instance list, and then we're going to install a very important package. So here we go. You basically run Ansible playbooks with Ansible playbook command and that YAML file that I just displayed earlier. And so it's going to go ahead and start with start test virtual machine on Dream Compute. Great. So, like always, we'll go ahead and refresh the dashboard, and we'll see a VM eventually that we'll be building. And should also, after it becomes active, we'll get a IP assigned to it since we specified the auto IP true option. Still waiting. Okay, so it should be done, and now it's waiting for SSH to be available on that. So we could see as well from the dashboard that it got a public IP, and now we have to wait for the important package that I was mentioning earlier that it got installed. And it got installed, and we can now SSH into it, hopefully. And so we go ahead and we SSH in. And now we can use that very important package of mine that was installed on the VM. Does anybody remember Cowsay? I'm bringing it back. In case you can't read that, it says, "I love OpenStack." Okay, cool. So this brings me to my conclusion of why we're making these improvements across OpenStack. I mean, a lot of us have been working on this project for a while. We love it. We are listening to people's feedback on how we can improve things. I just spilled out my guts to you on inconsistencies that have bugged me for a while. A lot of these has been improved in Newton, but we do it so people could do really cool stuff like this. Like this person was playing the guitar, was like, there was like muscle movement, being measured, and it was all running off of a cloud. It's pretty cool. That was being displayed at the Austin Summit. So yeah, cloud stuff does some cool stuff. And that's it. Thank you.